Today we're going to talk about some characteristics of polynomial graphs. You'll notice some similarities in this lesson to some of our previous lessons, where we talked about degree and number of terms, end behavior, maximums and minimums. We also have talked about our x-intercepts, but maybe not specifically the y-intercept, so I'll focus on that. And then increasing and decreasing intervals are something we talked about in previous graphs, but we haven't touched on that in polynomials yet. The first thing we want to do is graph this equation using our graphing calculator. When you do this, you may notice that you cannot see the entire graph in your current window. So one of the things that I want you to do is resize your window. We haven't done this yet, so I'm going to walk you through it step by step. Currently, my window is correct side to side, so the x-axis values are just fine. But my y-axis values are not large enough. The truth is, I really don't need to go up much past this local maximum. So I'm going to change my highest y value to maybe 5. So how do I pick that lowest y value? Where do I think that this goes down? By using my table, I can approximate where that lowest value might be. It's over here in the negatives. And so I'm going to go second graph so I can kind of get an idea of what's happening. You can see at -4, my lowest y value is -20. And it looks like at -3, it does dip down to -24. But then at -2, it comes back to -18. So I just need to pick a number that is lower than -24. So why don't we do -30? So how do we adjust those y values? You're going to go to the window on your graphing calculator. I told you we won't adjust any of these x values, so I want you to go first down here where it says y minimum. This is your lowest y value that you need. And we said that -30 would probably be a good minimum value. As far as the highest y value, I had said maybe 5. So let's push graph and see if this works. Great. Now I can see my minimum and I can see my maximum and I can tell the end behavior of each side of the graph. So now let me quickly sketch this graph. Obviously, my graph is not long enough to show all the bottom half of this graph, but I will do my best to just get a general idea of where it belongs. Okay, like I said, this is a rough sketch, but it at least gives me an idea of where it belongs on the graph. Degree. The first thing we're going to do is make sure that our polynomial is in descending order, which it is. And so that means that the degree, the greatest exponent in this polynomial, is 3. Now we're going to name by degree and number of terms. If you have a degree of 3, that means that this is a cubic polynomial and it has 3 terms, which means it's a trinomial. Now we're going to do our end behavior. Remember, when it says that x is approaching -infinity, we know it's talking about the left side of our graph. So where is the left side of our graph headed? It's headed to positive infinity. When it says as x approaches positive infinity, it's talking about the right side of our graph. Where is our graph headed? On the right side? To negative infinity. Okay, let's talk about our x-intercepts. I can tell that the graph crosses the x-axis 3 times. Remember, if you're wanting to check your guesses about where it crosses, you can look over here at your graphing calculator. And what you're looking for specifically is when y equals 0. So I can tell that one of my points is at 1, 0, and then I have another point at 0, 0. That would be these two. This one looks like it's at -5. If I need to move on my table, I will use second graph. And I'm going to go up here and look for -5. And sure enough, -5, 0 is my third x-intercept. So let's write those down. Y-intercepts. You have a y-intercept when the graph crosses the y-axis. It will only cross the y-axis one time. I think it's at 0, 0. The way that I can confirm, again, is to come over here to my table and I look for when x is 0, then I see where it crosses y. And sure enough, my y-intercept is at 0, 0. Local maximums and minimums. This graph only has one local minimum and one local maximum. We will use our graphing calculator to find each of these. I'm going to start with the minimum. I'll use second trace and I'll choose number 3. It tells me to go to the left side, so I'm going to have to use my left arrow to move over there. Now that I'm on the left side of my minimum, I'll hit enter. Now I need to go to the right side. Hit enter. It says guess, so I'll hit enter one more time. Now it tells me this is the minimum, and it is located at -3.2 and -24.2. Now let's find our maximum. We'll use second trace again, but this time we'll choose number 4. We need to go a little bit closer to the point that we want to find, but we want to remain on the left side. Once you're there, hit enter. Go to the right side. Hit enter. It says guess, so let's hit enter one more time. The maximum is found at 0.5, 1.4. Now it's time for us to find our increasing and decreasing intervals. We did this in the past with parabolas, and I always told you to start on the left and then go to the right. Trace the graph with your finger. We'll do this same process. If we start on the left, you can see that we are decreasing until we get to this lowest point, and then we are increasing until we get to this local maximum, and then we are decreasing once again. So this particular graph has 2 areas of decrease and only 1 of increase. So how do I know where the change occurs? The change occurs at the x values of my local maximum and my local minimum. I'm going to write these on the graph for you. Okay, so now you can see where these changes occur. Remember, when we are identifying our increasing and decreasing intervals, we must also add negative infinity on the left and positive on the right, because as we name an increasing or decreasing interval, we can only use x values. So we said that if we start on the left, we are decreasing in this first interval, and this interval exists between negative infinity and negative 3.2. Make sure that you write this on the correct line. This second interval is an interval of increase. This interval of increase exists between negative 3.2 and 0.5. The final interval is an interval of decrease, and it exists between 0.5 and positive infinity. I've gone ahead and put the equation into the graphing calculator. Let's graph it and see if we need to make any adjustments to our window. We will. I can only see part of this graph and I can't totally see what's going on. Let me zoom out to get a better idea. I can tell that this graph is not very wide, but it is definitely long and tall, and something appears to be happening right about here. The minimum probably is down in this region. So when I'm adjusting this window, I don't need my x values to be very wide. we might just pick -10 and +10 for our x values. But as far as my lowest y value, if I look over here at the table, I can tell that it goes down to -90. So I'm probably going to want to pick like -100, something a little bit lower. As far as this area, somewhere between 1, 2, and 3, there's something definitely going on. So I'm probably going to pick maybe around that 50 or 60 range to see if I can make sure and get this into my window. So let's adjust the window. Like I said, the x values, let's just pick -10 and +10. Remember my y value, I said I really needed to go down low, -100. But as far as the highest y value, maybe 50 or 60. Why don't we pick 60? Let's graph it and see if we can see the whole graph now. I can. I can see that minimum. I can see this maximum. I can see this minimum. So I've got all the points that I need to see. Let's go ahead and sketch this on our graph. Obviously, it's not all going to show up on there, but I can see some things like it looks like it's crossing between -4 and 5. Also looks like it's crossing at -1, and it doesn't touch at all on this side. All right, let's go ahead and start identifying some of the characteristics of this graph. The first thing is the degree. As long as your polynomial is in the correct order, your exponent at the front, your largest exponent, will be the degree of your polynomial. We're going to name this polynomial by its degree and number of terms. Since it has a degree of 4, it is quartic, and it has 5 terms, so it is a polynomial with 5 terms. Now it's time to talk about the end behavior. Remember, this first statement is talking about the x values as they approach -infinity, which means we want to focus on the left side of the graph. Where is it headed? Positive infinity. The second statement looks at the x values that are approaching positive infinity, so we want to focus on the right side of the graph. Where's the graph headed on the right? To positive infinity. X-intercepts. I can tell that the graph crosses the x-axis 2 times. If I look over here at my table of values and I'm looking for y's that are 0, I don't see any y's that are 0. So that means that it is crossing at decimals. And the way that we're going to figure this out is by using the calculate menu on our graphing calculator. So let's go to second, trace. We're going to choose number 2, zeros. Remember, the solutions are also called roots or zeros of the function. To find my first 0, I'm going to go find this one on the left. My calculator says that I need to be left of that point. Once I am on the left of that point, I will hit enter. Then it says to go to the right of that point. Hit enter. And it says guess. We'll hit enter again. So this point is located at -4.8, 0. To find our next x-intercept, we're going to do the same process. Second, trace. We're going to choose 0, and we're going to go a little bit closer to that point, but we want to stay on the left side. We'll hit enter. Now it says go to the right, so we'll continue past that point. Hit enter. And now it says guess. We'll hit enter one more time. So this x-intercept is at -1.1, 0. Our y-intercept is found by looking for when x is 0, and we can see that very clearly on our table. So my y-intercept is at 0, 24. Now it's time to find our local maximums and local minimums. This graph has 2 local minimums and 1 local maximum. Again, we're going to use our calculator to help us find these. We'll start with this minimum. Go to second calculate or second trace, and we're going to choose minimum, number 3. It tells us to go to the left of that point. Once you're on the left, go ahead and hit enter. Now it says go to the right. Hit enter. And it says guess, so we'll hit enter one more time. This minimum is located at negative 3.5, comma, negative 99.0. Let's find this maximum. Second, trace, and we'll choose number 4. We need to get a little bit closer to the point that we want to find, but remain on the left side. Hit enter. Now we'll go to the right. Hit enter, and it says guess, so we'll hit enter one more time. The maximum is located at 0.3, comma, 25.3. Now let's find our second minimum. We'll go to second trace, we'll go to number 3, and we'll make sure that we're on the left. Since we are currently on the left, we'll go ahead and hit enter. Now it says go to the right. Hit enter. And then it says guess, so we'll hit enter one more time. This minimum is located at 1.7, comma, 18.2. Now for our last 2 questions, the increasing and decreasing intervals. Remember, we're only allowed to use the x values to name these intervals of increase and decrease. To determine what parts of the graph are increasing or decreasing, we will start on the left-hand side and we will trace the graph and talk about what's happening. So in this section, we are definitely decreasing all the way until we get to this minimum. At that point, we are then increasing until we get to this maximum, decreasing until this minimum, and then increasing again. So this particular graph has 2 intervals of increase and 2 intervals of decrease. Let me label things and then we'll talk about how to name these intervals. All right, to help us, I went ahead and put our negative infinity and positive infinity on the graph, and I labeled the x values of our maximums and minimums. And I went ahead and put those on the graph also. I also labeled that we were decreasing here, increasing here, decreasing, and then increasing. So my first interval of decrease occurs between negative infinity and negative 3.5. Then I have an interval of increase between negative 3.5 and 0.3. Next, I have a decrease that occurs between 0.3 and 1.7. Finally, I have an interval of increase that occurs between 1.7 and infinity.